right, today we're going to tackle integrating with long division and completing the square. So we'll break them up into the first few examples with long division, the second with completing the square. So I can't stress enough, this is not the first thing I ever think of. We are always, always, always trying U sub first. And if and when that fails, we have to get creative. It may be an arc trig, or it may be one of these long division or complete the square. Okay, but again, it's U sub first 100% of the time. Now, if U sub fails, and this happens, then we'll go with long division. It says if the numerator's degree is either greater than or equal to the degree of the denominator, we need to first use polynomial long division. Okay, so long division when the degree of the numerator is greater than or equal to the degree of the denominator. So again, I just want to be clear. This question, well, let's say it says integrate. Let's slap an integral on there. And a dx, of course. Okay, we are trying U sub first. So in a fraction, we typically pick the denominator. I'm assuming you can do this in your head. U equals 7x plus 7. So du is equal to 7 dx, and I get du over 7 equals dx. I want you to picture rewriting du over 7. Is this going to cancel with a 7? Heck no, of course not, and U sub fails. Okay, but I am trying U sub first. I am never thinking, oh, let me do some long division. I am always trying U sub first. Okay, so now I look at it, and it obviously is an arc sine. There's no radical in it. And I'm thinking it's not arc tangent because these don't look like perfect squares and there's too much junk on top there. So it's got to be something else. So now I look at my fraction and I say, okay, the degree of the numerator, the squared, is greater than or equal to the degree of the denominator. So here's what we do. We go back to polynomial long divisions where we did a ton of this in Algebra 2 whenever you took that. So let's review how to divide. I'm going to take 7x plus 7 and do some long division now. Now, just as a reminder, you don't want to miss any terms. So if a term is missing, we want to put a 0 placeholder in there. So I'm going to say 42x squared plus 0x's minus 33. Okay, so now we're going to do our long division. So the deal was you're going to match these terms up. How does 7x become 42x squared? I multiply by 6x. And then I take that and I multiply by this whole term. 7x plus 7 times 6x. So I'm going to get 42x squared plus 42x. Now here's the most important part in long division. You have to subtract this whole row, which means you have to switch all their signs. So this becomes a minus. Scratch that off, that becomes a minus. You subtract the entire row. Now those will cancel, and I'm left with negative 42x, bring down the minus 33. Then you play the matching game again. How does 7x become negative 42x? Well, this time I multiply by a negative 6 only. So then I would get negative 42x minus 42. Play the matching game again. I'm going to go through and change all the signs. So this negative becomes a positive, and this negative becomes a positive. Those will eliminate. And negative 33 plus 42 is 9. Now, how do you write your answer up from long division? So we haven't done any calculus, right? Well, I mean, we attempted to do calculus with this U sub, but it didn't happen. So now we're trying long division. Now, when I write my answer up, it's what we got. So 6x minus 6, plus or minus based off what this is, so it's positive. So plus 9 over the divisor, that's 7x plus 7. Okay, so that's what you did in Algebra 2. Now, because we couldn't integrate this, we are now going to integrate our answer. So we're going to slap an integral on this answer with a dx. Now, 9 times out of 10, you're going to have to split, not 9 times out of 10, every time. You're going to have to split this up because this will always be a fraction based off what you divided by, and this is not in this case. So I'm going to integrate 6x minus 6dx plus the integral of 9 over 7x plus 7 dx. So I'm taking my answer from long division and I'm just going to integrate. So this side, super easy. I'm just using my power rule basically. So I get 6x squared over 2 minus 6x. Okay, now this side needs a u sub because I don't know its derivative off the top of my head. So u is 7x plus 7. du is 7 dx, and I get du over 7 equals dx. So I'm going to take my time and integrate this now. So I have 9. This became a u, and this is du over 7. So I have 9/7 du over u. Okay, so now your brain's saying, oh, that's somebody I know. When I see du over u, that's the derivative of the natural log of u. So this is 9/7 ln of u, which was 7x plus 7. So my answer is this plus this. So my final answer, I'm going to call that 3x squared minus 6x plus 9/7 ln of 7x plus 7 plus c. Now call me crazy, but I actually think these are a lot of fun. All right, so we'll try another one. This time just has some bounds on it, so we'll take an extra step with it, but obviously same idea. I'll put a little line here for myself. Okay, so again, I'm going to try u sub first. So u is equal to x minus 1. If I derive that, I get du equals dx. So clearly, if I just replace this with a u and this with a du, nothing's going to cancel. U sub failed. There's no radical. It's not arcsine. These are not squares, so it's not arctan, and that's not a plus. So now I'm back to this thing, the leftover thing, this long division. The degree of the numerator is greater than or equal to the degree of the denominator. Check. So I'm going to go back to long division. So I'm going to go x minus 1 divided by x cubed minus 5x squared plus 8x plus 4. Okay, so I need somebody to pause it. Let's put 2 minutes on the clock. Go ahead, talk yourself through the long division, and then write your answer down, and let's play it and see if we agree on the same thing. So someone go ahead and pause it. All right, see what you think of my long division. I ended up with a remainder of 8, and obviously my answer is here. I'll give you a minute to see if you made any mistakes. Obviously, I multiplied by x squared. I had x cubed and x squared, changed both signs to get a negative 4x squared. Brought down the 8, so multiplied by negative 4x. Again, changed the signs. That's how I ended up with 4x. Brought down the 4, changed the signs. That's how I got an 8. Okay, so now I'm ready to integrate my answer. So I'm going to slap an integral around the whole thing, and then I'm going to say, this is power rule, this is not. So I'm going to break it up. So I'm going to integrate x squared minus 4x plus 4 dx plus the integral of 8 over x minus 1 dx. Again, let's pause it and compare. So give me, put 2 minutes on the clock or so. So again, this was just the quick power rule, add and divide, add and divide, add and divide. Then I needed u sub over here, so u was my denominator. Du equals dx, so I had 8 over u times du, pulled out my 8, and I see that wonderful du over u again, so I know that turned into an ln. Now, because I plugged my original numbers back in, I don't need u bounds. I'm just going to go back and plug in my original bounds. Okay, so I'm going to plug in my 4. I'm going to get 64 thirds. 4 squared is 16 times 2 is minus 32 plus 16 plus 8 ln of 4 minus 1 is 3 minus, plug in the lower, 3 cubed is 27 divided by 3 is 9 minus 3 squared is 9 times 2 is 18 plus 3 times 4 is 12 plus 8 ln of 3 minus 1 is 2. Okay. Now the biggest thing, of course, is just to watch that subtraction sign. And obviously you're just adding at this point. I don't know how far I'm going to go here. 64 thirds. Negative 32 plus 16 is negative 16 plus 8 ln of 3. Distribute this negative. We've got minus 9 plus 18 minus 12 minus 8 ln of 2. And then again, I would just put my like terms together. And just for the sake of moving along here, I'm probably going to skip that part, but I know you know how to put like terms together. Okay, so that pretty much sums up long division. Again, we tried U sub first, it didn't work, so then we went on to something else. We thought arctan, arcsine, and then the last two things we have are this long division and completing the square. So moving on to what a completing the square type of problem looks like. It is useful when quadratics are involved in the integrand. So notice I see a quadratic here. So like this wasn't a quadratic, I can't complete the square. You can only complete the square on quadratic equations. So again, you did that in Algebra 1, you did it in geometry, tiny bit in Algebra 2. But I just want to stress, it has to be a quadratic to complete the square. So just a little refresher on what I mean by complete the square. Completing the square means you take that b term, you cut it in half, and then you square it. And then you add the number and also subtract the number. Okay, now why do you add and subtract? Well, because basically you can't change the equation. But if you add it and subtract it, you basically haven't changed the equation because you put a 0 in. If I said plus 5 minus 5, it's basically like saying 0, and I haven't changed the equation at all. So let's practice on this one. So I have x squared. My b term is 6. So I'm going to take 6, cut it in half, which is 3, square it, and I get 9. So I have plus 6x, and then I want to add the 9 right away, subtract the 9, and then that minus 5. Okay, so essentially I put 0 in, right, plus and minus 9. But notice it's you got to make sure you put it in the right order. You're going to add the 9 right after you complete the square, subtract the 9, and then the minus 5. Now put a little bracket here. This is completing the square. These three terms are going to factor as perfect squares. This is really x plus 3 and x plus 3. So we're going to call that x plus 3 squared. And then we'll just add those two together, so minus 14. Okay, and now that's going to be useful. Now, in these completing the squares, a lot of times they turn back into the arc-trig functions. So let me go back up to the top and remind you of those two equations. If we have du over the square root of a squared minus u squared, that is our arcsine. That is equal to arcsine of u over a plus c. If we have du over a squared plus u squared, that is our arctan. Whoops, it's 1 over a arctan u over a plus c. Okay, so these two are going to pop up again. If you complete the square, you're most likely going to revisit arcsine and arctangent. And just to recall, sine inverse is the same thing, and so is tan inverse of arctan or arcsine. All right, so let's try a completing the square method. All right, let's look at 3. So I can try u sub, right? Obviously, I want to do that first, so let me just write it here. If my u, my only option is the denominator, x squared minus 4x, its derivative is 2x minus 4. I've got du over 2x minus 4. Clearly, if I substitute that in, that 2x minus 4 is not canceling with anything, so u sub fails. This is not long division because the degree of the numerator is not greater than or equal to the degree of the denominator, so long division's out. And it's clearly not an arcsine or cosine at the moment, or arctangent at the moment. But it does have a quadratic, so that's where completing the square comes in. So we're going to square for just this part. So we're going to say we have x squared minus 4x. So let's complete the square. Take the b term, cut it in half. 4 divided by 2 is 2. Square it, and I get 4. So I want to add 4 and subtract 4, and then have that 7 there. These three terms will factor. So that looks like x minus 2 and x minus 2. So I'm really going to call that x minus 2 squared. And then I've got a plus 3. So I'm going to rewrite the equation. It is dx over x minus 2 squared plus 3. So I haven't really done any calculus at the moment. All I did was rewrite the equation so it looks a little differently. Now when I look at that, what do you see? What do you see when you look at that? Obviously, u sub is going to fail, right? Okay. If my u was x minus 2, its derivative is dx, that's not going to cancel with anything. U sub fails. But I do see a plus sign, and I see a term squared, so I'm thinking this is an arctan. So I'm going to say a is the number, a squared is equal to 3, and u squared is equal to x minus 2 squared. Therefore, a is equal to the square root of 3, and u is equal to just x minus 2. Oh, what did I write? X minus 2. Okay, so again, in arc trig, you need to figure out who you're squaring to get this, which is obvious, it's x minus 2, and who you're squaring to get this, which would be the square root of 3. Now I still need to do a u sub. So if I derive this, du is equal to dx. Because I still am doing a u, I have to substitute in my u sub. All right, so let's go ahead and write this out. So this integral is going to become, this is my u squared plus my a squared, and my dx is being replaced with du. So now I'm staring at the derivative of or the integral of arctan. So its rule is 1 over a arctan u over a plus c. So I'm going to say I get 1 over the square root of 3 arctan or inverse tan u over a x minus 2 over the square root of 3 plus c. And that's it. All right, last one. We just have a definite integral this time. Just kind of. All right, so I'm looking at the integral. I'm going to try my u sub. I'm going to use the denominator. If I take this guy's derivative, right, I'm going to get du over the derivative 2x minus 4. 2x minus 4 is not going to cancel with anything, so u sub fails. I can't go long division. There's nothing up top here. The degree of the numerator is not larger than the denominator, and I have a quadratic. That's what's jumping out at me is the quadratic. So I'm thinking now complete the square. So I'm going to complete the square up here. X squared minus 4x. So take your b term, cut it in half, square it, add it to both sides. So I'm going to add 4 and subtract 4, and I've got that plus 13. That's going to factor nicely to x minus 2 and x minus 2, which I can sum up as x minus 2 squared. Negative 4 plus 13 is going to be a plus 9. So all I'm doing, zero calculus, I'm going to rewrite the integral. This is really the integral from 2 to 5 of dx over x minus 2 squared plus 9. Okay? So no calculus has been done. All I did was rewrite the given integral. So now I'm saying, who is this looking like? Well, again, I don't see a square root, so arc sign is gone. I see a plus sign. I see squareds. I'm leaning towards arctan. U sub fails. All right, so who is the a and who is the u? And you do it in your head by now. What's the number you're squaring to get 9? Hopefully you've got a 3 there. And who are you squaring to get x minus 2 squared? Well, you're squaring x minus 2. All right, so let's carefully, oh, and I need du, of course. My du is equal to dx, how nice. And now we'll go ahead and write our integral. So I have, this becomes my du. This becomes my u squared plus my a squared. And now I've got bounds, so I can either replace them with u's, the u numbers, or I can plug the original back in and use the 2 and 5. It doesn't matter. At the end of the day, we should get the same answer. I'm going to, just for fun, I'm going to go ahead and replace them. If I plug a 5 into my u, my upper bound becomes a 3. If I plug a 2 into my u, my lower bound becomes a 0. Okay, so when I integrate this, I get the 1 over a arctan u over a, and don't say plus c this time, from 0 to 3. Okay, so a is a number, so I'm going to plug that in. So 1 over 3 arctan, my upper is going to be 3 over the a value of 3, minus 1 over 3 arctan, I have 0 over 3. Okay, so I've got 1/3 arctan of 1 minus 1/3 arctan of 0. Okay, now those again are numbers we should know. So arctan of 1. So again, we talked about being a great test taker, and when you get to do these practice exams, you're immediately going to put your table of trig values on your paper. Okay, so I'm picturing the trig value table. I don't have it in front of me, but picture the trig value table. We want arctan of 1. We want to know when 1 is the answer. So the tangent of who gets me 1 is the answer. Picture, close your eyes, picture the table. Tangent of who is 1. Hopefully thinking 45 or pi over 4. So I have 1/3 times pi over 4, which of course is pi over 12. Now, 0 is not on the table of values, but it is on the graph. Okay, the tangent graph at 0 hits 0. The tangent looks like this. So you either have to know it's a 0 or an asymptote. At 0, the tangent of 0 is 0, so that becomes a 0 and just wipes all that out, and I'm left with pi over 12. Okay, so lots of fun. Our goal today, I hopefully have a lot of time to practice. This was a rather short video, I think, maybe 22-ish minutes. We're going to tackle all of these. Can we, oh, shucks, we got to go separate sheet of paper again. I apologize. Just trying to save paper here. So separate sheet of paper. Hopefully all my answers match up. Again, you're going to try a U-sub first, because U-sub may work on some of these. What other hints can I give you? Oh, this bear here, number 10, be careful. One term on the bottom. Think about what's special with one term on the bottom. And again, some are going to be long division, some are U-sub. Talk yourself through them, use your notes, and work nicely with your partner. See you soon.